Welcome back to halogenoalkanes, and in this video we're going to look at the preparation of halogenoalkanes and in particular how we would do that in the lab, and this is a general method that we can apply to other organic families as well, but we're going to be preparing a halogenoalkane from the corresponding alcohol. So if you turn over to page 10, that's where we're going to start today. And we're going to have a look at the first of 6 methods of preparing halogenoalkanes. But this first one is by a long stretch the most significant and the one we're going to look at in the most detail. This method describes how we prepare primary halogenoalkanes, so that's halogenoalkanes, where the carbon that is attached to the halogen atom is directly connected to one or no carbon atoms. So in other words, the halogen is on the end of the carbon chain. And we're preparing those primary halogenoalkanes from primary alcohols. And just to remind you, alcohols are organic molecules which have a carbon chain that we represent as R, just as before, and then they have an OH group. And primary alcohols just means where, again, that OH group is on the end of the carbon chain. In other words, the carbon attached to the OH group is attached to, at most, one other carbon atom. So you're told here in your notes that bromoalkanes can be prepared from a corresponding alcohol by reacting it with hydrogen bromide, HBr. And we're going to look in particular at the preparation of 1-bromobutane by reacting butan-1-ol, its corresponding primary alcohol, with a mixture of concentrated sulfuric acid and sodium bromide. Why do we use that mixture? Well, that mixture of concentrated sulfuric acid and sodium bromide produces hydrogen bromide in situ. That's really important. So hydrogen bromide is produced in situ. So what that simply means is that we don't start with our butan-1-ol and just chuck in some hydrogen bromide. It's not added directly to the reaction mixture, but instead we use these other reagents, concentrated sulfuric acid and sodium bromide, and we put them in, and when they react together, they produce hydrogen bromide. So rather than adding in hydrogen bromide directly, we put in concentrated sulfuric acid and sodium bromide so that when they react, they will form hydrogen bromide that then goes on and reacts with the butan-1-ol. The method that we need to use to react these together is refluxing, which is continuous boiling and condensing, or evaporation and condensing of a reaction mixture. And we'll talk about why that's important later on. So let's have a look at our 2 equations for this reaction. So as we said, we need to form hydrogen bromide in situ. We do that from sodium bromide, concentrated sulfuric acid, and that produces hydrogen bromide in situ. The other product is sodium hydrogen sulfate, and this equation should look familiar. We met this equation in our halogens topic when we looked at the reaction of our halides with concentrated sulfuric acid. We also saw that hydrogen bromide is able to then reduce the sulfur within the sulfuric acid, but we'll come back to that in a second. This would have been the first stage of that reaction of our sodium halide or sodium bromide with concentrated sulfuric acid. What our second step is in this case is once we form that hydrogen bromide in situ, then it goes on and it reacts with butan-1-ol, that's this thing here. So C4H9OH, that's butan-1-ol, and then when that reacts with the hydrogen bromide that we produced in step 1, the hydrogen bromide that's present in the reaction mixture in situ, and they react together to give 1-bromobutane. And your side product is water. So you'll see how if we were to combine these 2 equations to give us an overall equation, if we were to add the left-hand sides and the right-hand sides, essentially our hydrogen bromides cancel. So now if we add the left-hand side and the right-hand sides of the equations, the left-hand side would read C4H9OH plus NaBr plus H2SO4. And that reacts together to give 1-bromobutane, or C4H9Br, plus sodium hydrogen sulfate, NaHSO4, plus water, H2O. So that's your overall equation, and I'm going to actually number these reactants 1, 2 and 3, and I'll come back to that in the method. You'll see in the next couple of pages we're going to look very closely at the method for this reaction and explain why we do each step, and we'll just highlight those reactants as reactant 1, 2 and 3. As we said, some oxidation of our hydrogen bromide will also occur. So remember, we talked about in our halogens topic how that bromide ion is a good enough reducing agent that it can reduce our sulfur within our sulfuric acid from +6 in sulfuric acid to +4 within our sulfur dioxide on the right hand side. So that is reduction. And as a result, what happens to our bromine's oxidation state? Well, on the left-hand side, it's -1. On the right-hand side, it's 0, just because it's bromine as an element. So that is increasing in oxidation state. So that is actually oxidation. So some oxidation of hydrogen bromide also occurs. But you don't need to worry too much about this side reaction, but do be aware that these products of this reaction can form, so bromine, sulfur dioxide and water. So that's why sometimes in this reaction, the reaction mixture turns, or you can see an orange colour. That will be because of your bromine. And you could see bubbles of gas being produced. That will be your sulfur dioxide. So what we're going to do now is start to look at the method of preparation. You'll see that it's quite a long method, and it would be rare for you to be asked to memorise and recall the whole method, but you could be asked for many of the steps within it. So it may give you the first few steps and say how you would continue to get your final product. And really it's about preparing the halogenoalkane this way, but also then purifying it to make sure that we have a pure product. This is the standard method of preparing a liquid halogenoalkane from the corresponding alcohol, so it doesn't just have to be for one bromobutane. That's the example that we are using, but you could use it to prepare other liquid halogenoalkanes. And in fact, it's really the basis of the method for preparing other liquid organic compounds. So you'll see methods at A2 that are very similar to this, but they'll have different reactants because you'll want to produce a different product. But this is the basis and the general method, standard method for preparing liquid organic compounds. So you will see this general method again at A2. You'll see many of these steps again at A2 in terms of the purification of the product. So you may want to write that down, that these steps will come up again. So what I'd like you to do at this point is to pause there and to watch the practical video that I have included the link for in your teaching videos document. It's not me carrying out this experiment, but you'll see it's quite helpful at giving you an overview of the method. You may want to read over the method first of all, but it might be a lot to take in before you watch this. So at least if you have watched this practical taking place or being done, then as we go through the different steps, you can visualise them and hopefully start to understand why we do the steps that we do. And as you watch the video, please follow along the steps with your notes and in your notes. So this practical, this method goes on to the end of page 14. So as the reaction is being done, please follow the steps in your notes and see if you can kind of keep up with what stage that you are at. They may not outline the steps word for word the same as they are in your notes, and the last couple of steps are kind of clumped together a wee bit, kind of rushed through, but I think it's helpful in actually seeing this method in action. So if you want to pause at this point, go and watch that practical video, and then if you follow the link to the next teaching video, I'll take you through the explanation of each of the steps of that practical.